Aldehydes, ketones, and carboxylic acid. They are represented as RCHO aldehyde, and then ketones, that is RCO. RCOR, and carboxylic acid RCOOH. Aldehyde, ketone, carboxylic acid. In fact, you have got the carbonyl group, C double bond O group, and that is supposed to be the queen of organic chemistry because you have got two differently electronegative atoms like carbon and oxygen. Since oxygen is more electronegative, there is a chance of transfer of pi electron, and thereby it becomes partially negative. And the carbon loses an electron, so carbon is carbonium ion. So this is the way the pi electron transfer, and thereby you are able to get different types of reactions. RCHO, that is, you have C double bond O. On one side you have alkyl group, on the other side you have hydrogen. So this is aldehydes. Ketone is C double bond O, and it is this C double bond O is flanked by or supported or surrounded by two alkyl groups. Either they can be same or different. So in order to distinguish, you can put R and R prime. So this is regarding ketone. And carboxylic acid, that is C double bond O, and here on one side you have R, on the other side you have OH. So it is simply represented as RCOOH. That is carboxylic acid. Now, let us try to write some structures of popular compounds as given in your NCERT in text questions. Alpha, take down. Alpha methoxy. Alpha methoxy propionaldehyde. Propionaldehyde. So how to derive the structure for this? Propionaldehyde is nothing but, that is, it has got three carbon atoms. One, two, three. And aldehyde is, we already know, C double bond OH. So propionaldehyde. Where alpha methoxy means, and this is the functional group. Which is the functional groups? The CHO is the functional group. This is aldehyde. This is the functional group. And the carbon atom attached immediately to the functional group is called alpha carbon atom, and the other one is beta carbon atom. So it is said alpha methoxy, means methoxy is OCH3. So it is routed through O, then CH3. Now you can fill up the bonds, fill up the each carbon atom with hydrogen. Make sure that each carbon atom has four valency, that is tetravalence. You got already one, so you can put CH3. And you got 1, 2, 3, so you can put H. So this is the way you have to practice the writing the structures. So what do you call it? Alpha methoxy propionaldehyde. And you can call it by IUPAC also. So propionaldehyde can be called propanal by IUPAC, right? Propanal. Yeah. Propanal. And here in the second position, this is the first position, this is the second position. You got methoxy. So this is the methoxy group. So it is present in the second group, second carbon atom. So you can call it 2-methoxy propanal. Then, now let us move to the next structure. 3-hydroxybutanal. 3-hydroxybutanal. As I already told you, that is, you should not leave any gap. So in IUPAC, you have to write continuous. So this is 3-hydroxybutanal. Nal means aldehyde. Buta means 4 carbon atoms. Hydroxy means OH, that is present in the third position. So a butanol chain should be drawn 1, 2, 3, 4. That includes CHO. So you can put CHO here. And then 3-hydroxy. This is the functional group FG. So this is the first one, second one, third one, fourth one. Means third one. So 3-hydroxy OH. Now fill up with hydrogen. CH3. This one CH and this one CH2. That's all. So if you want to expand the structure, you can expand. That is CH3, CHOH, CH2, and then C double bond H like this. And if you want to draw the bond line formula, you can do that. 1, 2, 3, 4. 1, 2, 3, 4. In the first carbon atom, you had double bond. So 1, 2, 3, 4. Sorry. You must have 4 totally. So 1, 2, 3, 4. So here 4. This is the first carbon. And 1, 2, 3. In the third carbon atom, you have this section. That's all. Okay. So 3-hydroxy and what is this? Butanal. This is the first position, second position, third position, fourth position. Right? Next. 2-hydroxy 2-hydroxy cyclopentane. Cyclopentane carbaldehyde. Cyclopentane carbaldehyde. So cyclopentane means it is a cyclic with the 5 carbon atoms. So it is a pentagon. This is cyclopentane. And cyclopentane carbaldehyde. The carbaldehyde is represented as CHO. In case of ring structures, when carbaldehyde is CHO is present, it is called a carbaldehyde. So cyclopentane carbaldehyde. And then 2-hydroxy. From this, you have to go in the clockwise direction. 1, 2. So 2-hydroxy. That's all. And if you want to expand this, CH, then CH4, and then CH, OH, CH2. So in each corner you have CH2, right? But if it is substituted, then it will lose one hydrogen. Okay? So the cyclopentane is drawn like this, which means on each corner you have CH2, 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 CH2. So instead of one hydrogen, you have got one CHO. Instead of one hydrogen from the second position, we have got OH. That's all. Now, di-secondary butyl ketone. Di-secondary di-secondary butyl ketone. Ketone means C double bond O, and you have got alkyl group on both sides, and that is indicated by what is that? Di-secondary butyl. Okay, so it is represented as di-secondary butyl. So how you can write down the secondary butyl? If it is normal butyl, you can write C, 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 which is normal. And butyl means CH2, 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 CH3. So this is butyl, that is C4H9. Butyl, this is N-butyl. Isobutyl means similarly branched like this and with four covalents. So CH3, CH3, CH2, CH. So this is called isobutyl. Secondary butyl means C, CH2, CH3, CH3. So this means secondary butyl. Okay. Now it is di-secondary butyl. So it is connected through the CH2. So you can put CH and draw the CH2, CH, and here CH3. Then similarly you have CH and CH3, CH2, CH3. So di-secondary butyl ketone. How to call it by IUPAC? Because this is not IUPAC. For IUPAC, how it should be called? Alkanone. So which is the longest chain here? This is the longest chain, right? So you can count from here. That is 1, 2, 3, 4, 5, 6, 7. So this is heptanone. And in the fourth carbon atom, you have double bond ketone. So 4 heptanone. So this 4 heptanone. And what are the substitutions? 3, comma 5. So 3, comma 5 dimethyl. 4 heptanone. You can call it heptafornone also. Then now let me write structure. You have to name it. CH3, C double bond E, CH2, CH2, C double bond O H. Can you give me the name? What are the function group present here? So if you have got ketone and aldehyde, which should be given priority? aldehydes. So this is 1, 2, 3, 4, 5 pentanide. Okay? So you can write down pentanide. But what about this? This should be called like a carbohydrate, when it is substituted as CHO. It was called a carbohydrate in the case of cyclic compounds. Likewise, here we should be called the oxo. So from here, 1, 2, 3, 4. So 4-oxo pentanide. Okay, you join this. 4-oxo pentanide. Can you name this compound? What is this? What is this? Fluoro. Hide this. What is this? Acetophenol. This should be called acetophenol. Where you have got the F. That is in the fourth position. 1, 2, 3, 4. So it should be called 4-fluoro and then acetophenol. That's all. Acetophenol.